Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Dzulkefli from group KA04. So today I would like to present final year project for Diploma of Civil Engineering. So our title is a lightweight concrete of U-shaped drain using bamboo charcoal and biochar. So first, I would like to introduce my group members. First is Mohamad Naim bin Mohammad Dzulhazmi. Second, Mohamad Affan bin Azman.
In this presentation, we have introduction, literature review, methodology, data and result, and discussion and conclusion.
In introduction, lightweight concrete blocks are commonly used in construction of houses. The construction industry is attempting to develop energy efficient buildings and materials as economic and environmental constraints increase in the coming years. Bamboo charcoal and biochar are used to make a lightweight concrete because it is eco-friendly materials. In research background, bamboo charcoal is made by carbonation from bamboo. It is a sustainable resource due to bamboo short growth cycle. Next, biochar is a carbon-rich, porous material made from waste biomass that has been found to have proven sorption potential for both inorganic and organic pollutants. The problem statement: first, many waste products contain substances in concrete that are harmful to the environment. Second, standard concrete components such as drain are quite heavy. Next, more manpower required to manufacture standard concrete. Our objective is first to produce a U-shaped drain using lightweight concrete with added bamboo charcoal and biochar. Second, to determine the optimum ratio of bamboo charcoal and biochar needed in order to produce the lightweight concrete. And third, to determine the strength performance of U-shaped drain using lightweight concrete with bamboo, charcoal, and biochar. The significance of the study: by developing this product, the cost of this innovative product will be cheaper than the standard concrete because the resources are renewable, become an option in new market. And second, renewable resources with easy access such as bamboo will present as green environment. This will serve as a way to promote an eco-friendly solution for the usual non-renewable standard concrete. And last, manufacturing concrete will require less manpower than the usual standard concrete while maintaining the strength efficiency between the two concretes. Expected finding: first, U-shaped drain using bamboo charcoal and biochar is lighter than using standard materials in concrete. Second, strength performance of lightweight concrete using bamboo charcoal and biochar is equal or not less than 30% from the standard concrete strength. And last, the optimum ratio of lightweight concrete using bamboo charcoal and biochar has been discovered.
Assalamualaikum and hi, my name is Mohamad Naim bin Mohammad Dzulhazmi and I will explain a bit of summary for the literature review. So this is the list of paper that we refer to in order to complete our research. Okay, so this is the analysis of the topic that has been discussed in the paper that we refer to.
Okay, now I will present about methodology. The methodology flowchart goes like this. First, we prepare the materials, which is the foam work, bamboo charcoals, and the biochars. And then to the experiment work, where we use mixed proportions of biochar of 0%, 10%, 20%, 30%, 40%, and 50%. Then go to the concrete mix process. After that, we went to the experiment test where we do water absorption test, compressive strength test, and finally the rebound hammer test. And then we gather all the result and analysis, and that's all. Okay, the first material preparation is the formwork. The dimension of the U-shaped drain formwork is 430 millimeters multiplied by 365 millimeters multiplied by 150 millimeters with 65 millimeters of thickness. Then we will determine the performance and compressive strength at 7 days. The next material is bamboo charcoal. Bamboo charcoal is a cylinder-shaped material and we obtain the material from Tadum Hill. The material will then be added as a hollow or voided material alongside the concrete mixture. The number of pieces is a fixed amount, which is 14 sticks. The next material is biochar. Biochar serves as a substitute for cement. Actually, it is a partial replacement for cement. And the ratio of biochar will be increased by 10% for each sample. We obtain biochar by crushing bamboo charcoal to bits until its size is comparable to that of cement. Next is the experiment work. The concrete will be made using 1:4 ratio. Biochar will be mixed alongside other materials to produce concrete, which is cement, rocks, and sand. The highest performing concrete will then be added bamboo charcoal to shape a drain. The proportions of biochar are as follows. The first experiment test is the compressive strength test. The concrete is poured into the mold and properly tempered to make sure there are no voids. The mold dimension is 100 millimeters multiplied by 100 millimeters and multiplied by 100 millimeters. The specimen's top surface should be level and smooth by applying cement paste to the whole cement and spread evenly. After 7 days, the specimens will be evaluated using the compression testing equipment. The compressive strength of concrete is calculated by dividing the load at failure by the area of specimen. The next test is the water absorption test. First, dry the specimen to a constant weight. Then weigh it and submerge it into the water for a predetermined length of time and weighing it again. The average absorption of test samples should not be higher than 5%. The last test is the rebound hammer test. The rebound hammer test is a non-destructive testing method of concrete, which provides a convenient and a rapid indication of the compressive strength of the concrete. The average rebound number of test formwork should be higher than 20, which is fairly level.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naim bin Mohammad Dzulhazmi, and I will start explaining for the chapter 4, which is data and result. In this chapter, it will contain with data and analysis that we collect throughout the process for making a lightweight U-shaped drain. This chapter will cover masses finding, compressive strength test, water absorption test, and rebound hammer test. This chapter's aim is to collect the full data on the test for water absorption, compressive strength, and rebound hammer to obtain the best sample for U-shaped drain. Okay, we start with the presentation for the wet concrete. So this is the result of wet concrete, which is aligned with our objective to make the lightweight concrete. The table presents the average weight of concrete with different percentage of concrete biochar at day 0 before immerse the concrete in water as known as curing process. As for the data number that hold the highest weight is 2,323 gram, which is control concrete. And for the lowest weight number is 1,982 gram for percentage of 50% biochar. As stated in chart, shows the average of 4 sample concrete for each percentage of biochar. The results show that after reaching 10%, it started to show that the significant weight between control concrete. Based on the result, we can conclude that using different percentage of biochar affect the weight of concrete. The relation for this experiment is more uses percentage of biochar, the less weight of concrete.
In this study, we use the 10% of biochar as optimal weight, which is not too light or too heavy.
So as we can see, the data show that compressed strength decreases with the addition of biochar. However, an additional of 10% of biochar showed almost the same potency as standard concrete. So we choose the 10% of biochar as our optimal ratio for our lightweight concrete. So this is the graph for the compressive strength. As we can see, the graph is decreases.
Okay, so we will move on with the water absorption test. Table shows the result of the water absorption test. There is 3 samples on each designated percentage of biochar. Each sample's weight was measured before curing and after curing process. The sample were immersed in water at room temperature for 7 days. This is the water absorption chart. We can calculate the absorption percentage by using the formula, which using difference in weight between biochar and control, and divided the control weight, and then times the by 100, and then we can get the percentage for water absorption. Other than that, based on the chart, we can see the increased number of percentage of water absorption as the number of biochar increases. Therefore, we will use the percentage of biochar, which is 10%, because it is almost similar with the control concrete.
And this is the graph for the rebound hammer test of U-shaped drain. As we can see, the average strength for lightweight concrete is quite comparable than the standard concrete, which is the lightweight concrete has 22 megapascal and the standard concrete has 32 megapascal.
And finally, we come to the discussion and conclusion. The discussion and conclusion is 10% of biochar rate is the only viable and reasonable option. After 10%, the strength becomes gradually decreased and the concrete grade poor is a poor concrete. Then biochar should be able to compete with silica fume as cement replacement. Silica fume is widely renowned in the market as partial cement replacement. Bamboo charcoal does not bring significant change, but while it did say that, but bamboo charcoal does reduce the weight of the concrete U-shaped drain by a little bit. Thus, the conclusion is more added materials equals to less weight and strength.
So as a closure, thank you so much and hope that our presentation had give you a clearer understand for our project. Thank you.